So welcome to this lecture 7 of the experimental stress analysis, and we'll talk about the biaxial stress states, or as one of the fourth keys for arrangement of the strain gauges. As a recap, we talked of the first three states. The first one was the uniaxial state, where we said the loading is along one axis, xx, and the strain gauge must be located along that axis. Next one was isotropic stress state, where the stress at any point is the same and the strain gauge can be located at any point. And the third one was a pure torsion state, stress state, and in this case the normal stress is at 0 and the body is exposed to only the shear stress, and the strain gauge is usually located at 45 degrees to the angle, to the axis of torsion. So the fourth case now, which you are going to discuss, is the biaxial stress state. Okay, and in this case the loading occurs in the two axes, say x and y, and is defined by the strain field. The strain field is defined by the strains in those directions, the principal stresses, the principal strains, and so forth. So there are two cases to consider. One, the first case to consider is when the state of stress is unknown. That is, the state of stress is unknown, but the directions of the principal stresses. Do you know principal stresses are usually perpendicular to one another, where this refers to the maximum and this refers to the minimum. Okay, so we say the directions are known. Okay, then the two element strain gauge rosette is used. Okay, so if I can illustrate that, what that means is you have this body, and you see the stresses. These are the directions. Okay, say this is the direction 1 and this is the direction 2. So the principal stress, the first principal stress, is on this direction. So the strain gauge measuring the second principal strain and the first principal strain will be located as such. Okay, and in this case the principal stresses, that's the first principal stresses, will be determined by this relationship. Okay, whereas the second one so where this is a Poisson ratio This is the Young's modulus, the Poisson ratio, the principal strains, which are directly determined by the strain gauges. Okay. Now the second case of biaxial strain is when the stress field, that is the stresses and their directions are unknown. Okay. So in this case we use a 3-element rosette of strain gauge. Okay. And so what happens if I'm straight? So we have this as the axis. So we'll have the gauges. We'll have the strain gauges, 3 strain gauges. So here we have the first strain gauge, the second strain gauge, and the third strain gauge. So that's a 3-gauge rosette. So we call this one. Can call this A. This is B, and this is C. And they are at an angle alpha A. This is at an angle alpha B. And this other one is at an angle alpha C from the x-axis. From this x-axis. Okay. So next I want to write the relationships of determining the strains. So this gives strain A, this gives strain B, and this gives strain C. So how do we determine those the relationship between those strains and the strain fields? Strain fields is this strain and that strain. Okay. So from your solid mechanics, if you check carefully, this relationship can be used. So E, the strain given by the strain gauge A, be determined as such. For A plus EYY sin squared alpha A plus the shear strain cos A sin alpha A AB EXX squared alpha A for B YY sin for B y cos alpha B sin sin alpha B. And finally EX sin alpha C as this is squared. This is squared y cos t sin for C. Okay. So these equations. So these are the strain fields. That is the strains xy, the strain in the x, strain in the y Cartesian, the Cartesian strains which define that. So from this equation, it will be possible to determine the principal strains E1 and E2 as follows. So the principal strains be determined by this relationship. Okay, similarly the minimum, so this is the maximum principal strain, and this is the minimum, which is just the opposite. Okay, where this is a shear stress. Okay, and the directions. Okay, and the directions are given as tan 2 theta is equals to shear strain So this is taken from the Mohr circle of stresses. So this is something you can remind yourself from Mohr circle of stresses. So the angle theta 1, so if we can define angle theta 1 is the angle between x-axis and maximum, and angle theta 2 is the angle between x-axis and E2. That is, if you have E1 there, okay, so this is theta 1. Then if you have E2 there, theta 2. Okay, so the principal stress stresses can be written as earlier written, which is now and similarly okay. So the three element rosettes will be fixed anchors. The one alpha B and alpha C are used to provide sufficient data about the strain fields, and they help to give us the principal strain and the strain fields, then the principal stresses. Okay, and that is very important. So next we shall introduce, based on that concept, we shall introduce on how do we analyze rosettes. Rosette analysis. Okay, basically this is the arrangement of strain gauges for measurements of strains and stresses. So that will be our next lecture. So thank you.